My name is Chris Rogers. I'm a technology evangelist at Zerto, a HP company. So I'm going to talk to you today about data protection in the hybrid cloud era. And what does that kind of mean, and where do we go, and all the different concepts we need to consider. So first of all, I just want to kind of show people, where Zerto came from, and we had a great introduction there. So yes, so from 2009 we were founded. 2011 was our first product, and all the way through to 2022 and onwards now, you can see the development we've had all the way through. So adding different pieces of the cloud journey as cloud has become more popular, and then most recently adding things like to ransomware recoveries. That's now one of the biggest problems in our industry. And along the way, we've had, we've accumulated 1,500 partners, over 350 managed service providers that offer DRaaS to our customers. And then some of the biggest names in the organization with strategic alliances, so AWS, Microsoft Azure, VMware, Google Cloud, et cetera, et cetera. So that's kind of who we are, what we do, and then this is our product. So the tagline for today and for the rest of the year is continuous protection for any app, any cloud, and any threat. And what does that really mean? So it kind of falls into three main pillars for our customers. So first one being ransomware recovery. Very topical for everybody at the moment, and top of mind for a lot of C-level execs and all the way down in the organization. How does Zerto actually help with ransomware recoveries? So we give our customers the ability to resume in minutes to seconds just before an attack. So if we're talking about the actual recovery side of a cyber attack or ransomware attack, no one can get you up quicker than Zerto with less data loss. And then if we take that same theme through to disaster recovery, I mean, ransomware is obviously a completely different beast, but the same outcome, right? You have no access to your data, your infrastructure, or whatever you're running. So in a way, it's similar to disaster recovery. But again, we've been doing this for many, many years now. Foolproof disaster recovery with the fastest RPOs and fastest RTOs in the industry. Super simple to use, super easy to install, full orchestration, automation. And then we move into the multi-cloud mobility and multi-cloud agility story. So giving organizations the freedom to innovate across clouds, not be constricted to a particular vendor, a particular cloud, or a particular set of hardware or storage. And then all of that is underpinned by continuous data protection. So that's something Zerto has been doing since its inception. So we've been doing that 11 plus years now. And it really is the core of everything we do at Zerto. So the core of our product and how we actually do what we deliver today. So if we look at continuous data protection in a little more detail, what does it actually mean? Well, it's not just getting data from A to B, right? That's relatively straightforward. People have been doing that for ages, right? But actually, we think continuous data protection is made up of our core three kind of differentiators in the marketplace. So near synchronous replication. So if you guys are aware of Zerto, you'll know what we do, you know how we do it. But if you're not so familiar with Zerto, so essentially we're a software only solution. So we don't have any boxes, any tin landed anywhere. We're completely software only. And we essentially intercept the writes through the hypervisor of your virtual machines, and we send them to a secondary location or tertiary or beyond within seconds of them happening. So typically we'll see RPOs with between 5 and 10 seconds is typical across a Zerto estate. So again, we're not scheduling anything. We're doing that on a continuous basis, hence why we call it continuous data protection. So we don't schedule anything. So you're not setting up a schedule and saying ship this data every X second or every X amount of minutes. We're doing it on a continuous basis. So that those RPOs can go much lower than 5 seconds. I've seen environments that are 1, 2, 3 seconds. But if you have like a slower network or something like that, then we'll automatically adjust the RPOs to make sure we're not doing anything untoward in your environment. So potentially up to 10, 20 seconds, depending on environmentals. But we're hardware and storage agnostic as well, meaning that it doesn't matter what storage you're running underneath, what compute you're running, or actually what hypervisor you're running, or even what cloud you want to go to. We're completely agnostic in that front. So we don't mind whether it's Pure and Dell and HP or the mix of everyone, because we don't want to tie you to any particular vendor. The beauty of and the simplicity of Zerto is we don't have any snapshots taken, so we don't have that production impact on workloads. We don't have any agents inside of the operating systems either. So from install to protection, that could just be a few hours. So from completely vanilla estate all the way through to getting CDP and Zerto up and running, it can only be a few hours. So very, very simple. And then also we can replicate to multiple places at the same time. So that really kind of bakes into this hybrid cloud strategy that I think is probably the most dominant IT strategy on the market these days, taking the best of what's available in certain areas, so SaaS, PaaS, IaaS, and then on premises, and then choosing the workloads to run in those places at the right times. And then secondly, if we look at the recovery point, so the granular point in time recovery. So again, if you know Zerto, well, you would have heard Zerto present about the journal many, many times before. But for those who are not so familiar, Zerto's journal enables us to keep a track of everything that's changed across those virtual machines, from anything from 1 hour all the way up to 30 days. So when I'm talking about RPOs of 5 and 10 seconds, I'm not just talking about the RPOs for the last 5 or 10 seconds. That could be 5 or 10 seconds all the way back to 30 days previous. So giving the users super granularity on the exact point in time they want to rewind and resume their data and operations to. So if we were comparing that to kind of legacy solutions, when we're taking a backup or a snapshot once a day, we're going to be losing 24 hours worth of data loss, and potentially, as technology's got better, we're now up to maybe 4 or 5 times a day, so maybe 4 hours worth of data loss. But still, that data loss is massive. If we're talking about this always-on world, we don't want to be losing any data. Data is one of the most valuable assets in the world right now. So minimizing that data loss is going to be crucial to pretty much every single organization on the planet. And this ability helps us neutralize those ransomware attacks. So on the figure here, we can see a disaster hits at 10 a.m. And that could be a ransomware attack. That could be a hurricane. It could be a fire or flood. It doesn't actually really matter what the trigger is to us. So we can then choose a point just before that event occurred. So let's say it's a ransomware attack or a lockout or just a simple crypto lock or something like that. We can just rewind the data we want back to that point in time and carry on as if nothing ever happened. So really giving that kind of granularity and that back to customers. And when we say disaster recovery, most people are thinking, well, I don't want to fail over everything in my whole site. We can obviously do that, but we can also do individual applications, individual virtual machines, and also individual files and folders from in those virtual machines, all without any agents inside as well. So giving that kind of solution that people want, so being able to get your Word doc that is on the file server back from 5 seconds previous after, Karen, maybe your cat ran over the keyboard that we saw earlier, but getting that back from 5 seconds previous with pretty much minimal data loss directly back in production without any of the overhead of running agents or anything else like that in the virtual machine. So a really great solution. And then the last thing I want to cover on the kind of the continuous data protection side of things is our application-centric recovery. So when we're making up enterprise applications of virtual machines, very rarely, or I haven't come across many, where they're a single VM. Right? They normally have, like we can see on the slide here, so 4 or 5 layers of virtual machines, database, file, app, front end, whatever you want to call them, but they all have interdependencies between them. So there's no real point in just recovering one part of that. We want to recover the whole application. So, but when we've traditionally done data protection, we've always just taken those component parts, protected them individually, and then re-stitched them back together again on the secondary site or the tertiary site, wherever it may be. But the way we do things at Zerto, we put those all into a virtual protection group. So it means whenever we're doing our checkpoints every 5, 10 seconds, say, that's consistent in time across all those applications and all those virtual machines in that app, which means when we come to recovery, recovering is as a single entity rather than its component parts. So we don't have got to wake up the DBA at 3 a.m. to get him to do redo logs or get the front end guys to check everything's in sync, because everything's exactly the same point in time. So it avoids that horrible staggered backup window where we're restoring the DB from 1 a.m. and then the front end from 5 a.m. and all those types of interdependencies where we have to try and figure out which one's got the best copy of the data in. That's all from exactly the same point in time. So now we understand continuous data protection on virtual machines. I kind of want to show you what the landscape looks like with hybrid cloud data protection with Zerto. So if we look here, we've got disaster recovery and backup within private clouds. So, we've got data flowing between our data centers there, and we're going back again. So that can either be a two-way replication or fail over, fail back, however we want to configure that. So that's pretty standard for people. That's going to be relatively old hat. But that's the first step on our hybrid cloud journey that most people have come from. And now we're going to add disaster recovery and backup to cloud environments. So that might be going to a public cloud, so Azure or AWS, for instance, or it could be, a VMware on Google Cloud, for instance, so a VMware Google Cloud Engine. This could be one of our 350 managed service providers that offer disaster recovery as a service out to our customers as well. Again, that doesn't matter to us, but enable to do disaster recovery and backup to the cloud from your on-premise data center as well, all whilst continuing the replication on premises if you want to as well. And then we can also push that out to a secondary cloud environment as well. So really unlocking this multi-cloud hybrid cloud strategy that many organizations want to adopt now, being able to choose AWS, Azure, Google Cloud, VMware Engine, disaster recovery as a service, and on-premise, and a myriad of all those things, but having up to 3 different replicas of the data, potentially in 3 different cloud environments, can be really powerful for your organization, choosing the right workloads to go to the right place at the right time. And then we have disaster recovery between clouds. So just because we're running in an AWS, in an Azure, or in a service provider, it doesn't necessarily mean the threats don't still exist. We know that you know, Cloudflare have outages and AWS have outages and everyone else has outages, just the way everyone. And sysadmins still exist all around the world. I used to be one myself, so I'm allowed to say this. I've fat fingered many a keyboard in my time and been up for the next 3 nights trying to fix the problem. But those problems are still going to exist. We do have ways of getting around it, you know, things like that, but we still need to be able to do that. So being able to do disaster recovery between clouds is important as well. And then also being able to back up data within and between clouds. Again, so the most popular use for this for Zerto is kind of SaaS applications. People are storing data inside of these SaaS apps, and they're not really thinking about the protection of that data much. They're just kind of looking at it from a holistic view and, oh, someone else has got my app, someone else has got my data, that's fine. And then last of all, enabling mobility across all of these platforms as well. So not being tied to any particular vendor. If you've gone into AWS and you fancy moving to Azure, that's absolutely fine. We can enable that with Zerto. If you want to move regions between public cloud providers, great. If you've got a DRaaS provider and you want to move to a different one, we can enable all of these things using Zerto's technology. So let's just dig down into Zerto for virtual machines and kind of dig into the actual architecture and the components to make that up. So we're talking about Zerto VMs. We don't do backup within clouds for Zerto VMs, so I want to make that kind of clear. So that one's been grayed out. But all the rest of the use cases, absolutely we do. So the first things first, we're a software-only scale-out architecture. So very simple, very easy to understand, and hopefully it won't take me too long to explain what each of these components do. But the first one being the Zerto Virtual Manager. This is like the quarterback of the Zerto solution, right? This runs the show, it's the management component. It knows everything that's going on in all the environments it's replicating to and from. So it runs on a Windows server, or very recently we've actually launched our Linux OVF appliance as well, so a hardened Linux appliance. So if you are in a Linux-only house, you can now deploy Zerto on Linux, which is a great thing. And it has a one-to-one relation with vCenter. So whenever you have one vCenter or Hyper-V SCVMM on premises, you're going to have a single Zerto Virtual Manager, either Linux or Windows as well. And then we move on to the virtual replication appliances. So these guys actually are the worker nodes. These are the ones that do the continuous data protection, do the replication of the data. And how we achieve our scale-out architecture is by essentially, we have a one-to-one relationship with VRAs to hosts. So the more hosts you have, therefore the more VRAs you have, therefore the more production workloads you can support, therefore the more replication workloads we can support. And that's true going the other way as well. So, you know, a lot of use cases are great because we want to then reduce our on-premise footprint. Maybe we're moving into public cloud, cloud native, you know, those SaaS applications. We want to reduce that footprint. Well, guess what? As soon as you remove ESXi hosts from your environment, you remove virtual replication appliances automatically, and we're not left over with big proxies or hardware or things like that we're not going to be using to a potential. So we reduce capacity and increase capacity on demand with auto deployment and auto load balancing available as well. So if we look at our architecture, it's very simple, very easy to understand, hopefully. We've got two components on the screen. We've got our Zerto Virtual Manager and our Virtual Replication Appliance. And you can see we've got the same in production than we do in DR. So it's a very simple mirror image design. So the same components on each site. And if you look at the kind of the arrows we've got going, we've got a local copy of the replica coming back to the same data center. So that would be for things like operational recovery, so individual files, folders, instant virtual machines, straight back to production on production grade storage, back to exactly where they want to be, or individual apps, that type of thing. But then we've got a copy going over to disaster recovery site as well. So that gives us the ability to change sites. If we have power outage or more environmental issues, then we can just move those across to our disaster recovery site with the same granularity and same RTOs. And then we also have two copies of the data going to offsite repositories. So this could be an offsite repository in the DR site, so like a Cloudian or an S3 compatible device that you have, or it could be inside of a public cloud, so AWS S3 or Amazon, Azure Blob Storage as well. But the important thing here is we're going to mark those as immutable. So those copies that we're taking outside of the environment and putting somewhere else, we're marking those as immutable, so no one can touch them. That's the break glass copy, as if everything was to go wrong in our world and everything were encrypted and everyone did everything, we still have this copy that no one else can touch. We can restore from that if we need to in the worst case scenarios.
Hey, Chris.
Yeah.
Sorry to interrupt.
No, absolutely.
Can you expand, or will you be expanding a little bit about how that immutability happens?
Yeah, so I haven't got any slides on it, but I can explain essentially. Yeah, so
okay.
So essentially, the long-term retention copy or the immutable copy, so we're taking that from the journal. So the journal that we explained earlier, we're taking a copy from the journal. So We don't have any production impact whilst we're taking that. So for large databases, things that change, we're still not backing them up in the traditional way. We're just taking it from the copy. And when that lands on the storage, we're essentially inside of our software marking that object as immutable inside the storage. So inside of Amazon S3, we're using object lock, the same as inside S3 compatible, and the same as Azure Blob Storage. So we're using the kind of the underlying storage technology to lock it, but we're controlling that from within inside our software. So you don't need to send the data off and then manually go in and then mark it as locked or anything. We handle that life cycle for you. So you can lock it for a certain period of time and that type of thing. So as soon as that time runs out, then we obviously unlock it and then delete that data as well, and so on your retention periods.
Okay, so you're using, for instance, Azure's features for immutable storage, not developing your own or anything like that.
Yeah, exactly. We're using the underlying storage. Yeah. So yeah.
Thank you.
If we look at the public cloud architecture, obviously it has to differ to the on-premises architecture because we don't have access to hypervisors and everything else like that. I'm sure Amazon and Azure wouldn't want us to do that. So we've built a custom-built Zerto cloud appliance. This is available from both of the marketplaces, so from AWS and Azure. Runs on the Windows machine, very easy to install and use, and it's the same component that runs in the Zerto Virtual Manager, but it also combines the VRA inside of that as well. So it does both components in one. So it does the management and the replication as well. But what we've done is we've actually built it for cloud. So instead of just lifting and shifting our solution inside of public cloud and saying, hey, this Windows machine now runs in the cloud, we've purpose built that. So we're using things like cloud native scaling. So for the majority of the time, our data is going to be relatively idle and just replicating on what I call like idle replication. It's just going to be going in and storing that data. So we don't need huge amounts of capacity to do that, for compute that is. But if we start wanting to do larger amounts of data, or we're doing like a failover live or a failover test action, we can then use Azure scale sets or worker nodes, if you will, inside the public clouds to kind of increase that capacity upon demand. And then as soon as we don't need that extra capacity, we can then scale those back down again. So that kind of drives big TCOs for organizations as well, because they're not having to build for peak all the time. We essentially have a baseline set of replication going on, and then we can expand out as we need to.
Hey,
and we only store, yeah, absolutely.
I've got a couple questions about the cloud appliance. One thing that jumps out at me that's interesting is you're running on Windows Server.
Mm-hmm.
That's an interesting choice, because I just typically a lot of these appliances we see running on Linux. Was there a reason behind choosing Windows Server as the operating system for the appliance?
Only essentially because that was where Zerto came from. So we first developed on Windows Server, and as we've moved through, it was just we kind of took the core code and moved it into there. I believe we are working on moving it to Linux. So you'll see in later presentations we have more things that are developed on Linux. So you'll see that stuff starting to come through. But yeah, at the moment this one still stays on Windows at the moment.
I mean, I have no problem with Windows. I've got my Windows, laptop right here. The other question I had was regarding the scaling. Mm-hmm. Is that something that is done automatically, or is that something that someone has to go in and bump up the scale sets? Do you provide metrics that are tracked to determine whether it needs to scale or not?
Yeah, so essentially all the I/O that comes through the cloud appliance goes into an Azure queue. And then we monitor the Azure queue, or the equivalent in AWS. We monitor that queue for the stats, and then we spin up based on an algorithm of that queue size. And essentially what we've done is we've tuned the scale sets for a maximum. So the maximum is 41, if you want to know. And that is essentially how much I/O we can pull from a single storage account without maxing out the I/O limit on the storage account. So we could do 101, but it would have no difference on the amount of time because we'll just be hitting another limit in public cloud. So we've kind of really targeted to get max performance out of the platform we're running on, if that makes sense.
So obviously we all understand the infrastructure that Zerto has to protect data. What about Zerto itself? The high availability features and how it fails over? Is it automatic? How long does it take? How does it replicate all the things that it needs to replicate? So a site fails, what protects Zerto itself? Can you explain that a little bit?
Yeah, absolutely. So in this instance, we're running all components in both places. So you can see on my screen here, if we're running in production and in Azure, we're running management and replication inside of production, and also that in disaster recovery as well. So if a whole site was to go down, obviously on premises here isn't going to be available for us to log into, right? It's dead, it's gone. So we log into the cloud appliance or the management component on our disaster recovery site, and everything gets triggered from that side. So we don't actually need high availability in terms of like if the Zerto Virtual Manager fails on site, we do have things like clustering, so you can cluster the Windows application to do like patches and things. But in actual disaster recovery situation, if that were to go down, then then you'd log into the one on the disaster recovery side. For things like VRAs, if a VRA were to crash or deleted or whatever happened, essentially we can just automatically evacuate the VMs onto different hosts, and the VRAs across all the other hosts would start picking up the replication to the other side. So that's how we kind of handle those types of outages. Does that answer your question okay?
Yes, yeah, of course. I mean, because the concern obviously is that when a site goes down, you are basically in a panic situation, and you want the minimum amount of work to bring your disaster recovery process to come online. So the less number of steps are there to recover from that situation, the better.
That's a perfect segue, because actually, if anyone knows Zerto incredibly well, everything we do is automated and orchestrated. So actually, once you've logged into the management, you can actually fail over a whole site in about, I think it's 4 clicks. So you can get up and running and fail over that whole environment in 4 clicks. So when you're talking about panic scenarios and a run book, guess what? Your run book is log in, click this button, and this button, and guess what? You're failed over in your environment. And because Zerto can do non-impactful testing, you'd have tested every single week for the last 2 years, ready for this moment. Obviously, everyone does that, right?
Exactly. Thank you.
So as you can see, the architecture here, we've got ZVMs, VRAs, and ZCAs. So the ZCAs obviously combining those two things, but you still have that ability to take that offsite copy and store it inside of, maybe if we're running Azure, maybe we want to store it in AWS to give ourselves that kind of extra level of security away from where our data is currently being stored. We also have that local copy still being replicated, because maybe we don't want to fail everything over into Azure all the time. Maybe if it's a single VM or a single app, we just want to restore it back to where it was in place and run as if nothing ever happened from 5 minutes or 5 seconds ago. And exactly the same architecture if we're architecting inside of AWS. You just go to a different marketplace, deploy a different appliance with a different package, but exactly the same. And instead of using blob storage, we're using Amazon S3 storage to store the data in. But again, still using that immutable copy if need be. So if we're looking at continuous protection for any app, any cloud, any threat, this really is kind of what we're giving users. So mitigating disruptions, whatever that disruption may be. Sysadmin, fat finger in the keyboard, through to the ransomware, whatever it may be, we're minimizing those disruptions. We're unlocking that multi-cloud and hybrid cloud approach. So, you can start utilizing public cloud in the way that you need, whether that's, a VMware on public cloud offering, a native public cloud offering, maybe it's disaster recovery as a service in a service provider. We're giving that ability to use the same tool for whatever your use case there. Simplify migrations. We have a purpose-built workflow, which is instead of failover live, failover test, it's move. And we guarantee a 0 RPO, and you can move your applications into cloud and also back out again, which I think is really important, not being locked in. And then with that simple, easy to use automation, orchestration, etc., we've explained improving operational efficiency, because disaster recovery, however I stand here and make it sound amazing, isn't the sexiest of topics most of the time. It's not the top of everyone's agenda to talk about first thing in the first meeting, right? So we need to make sure it's easy, simple to use, but effective. So it still is very important for most organizations.